All right. Well, first of all, thank you for inviting me to present today. This is certainly a unique opportunity for me. I've presented quite a few webinars. However, I have not presented any that are being live translated to another language. So I think it is exciting for me. Good morning from the U.S. It is about 11 o'clock here, so about 5 p.m. there. So good evening to you all. Thank you for taking the time to join in today. As Javi mentioned, I am going to talk about drones, and I'm going to talk about some of the new emerging technologies, some of the things we are doing in our program at Virginia Tech, as well as some of the things that I see moving in over the next few years, possibly even over the next decade, some of the way things will be changing. As Javi mentioned, I am a turfgrass pathologist at Virginia Tech. Primarily work with diseases. However, I have made a major transition to doing a lot of remote sensing applications, a lot of both disease detection and other stress detections, things such as drought stress, nitrogen stress, when we need to apply more fertilizers, when we need to apply less fertilizers. Javi and I were talking a little bit earlier today, and we were talking about the European model for managing turf versus the US model. We certainly overdo things a lot. I will certainly admit to that. I think we over-apply in many cases and over-irrigate. We use too many resources in many cases. Not always, but in many cases. I think things are changing a lot, and we'll get into that as we go through the presentation. I would like to start off and say congratulations to Spain, to all of Europe for a thorough butt kicking that you gave us in the Ryder Cup. It was a complete domination, and certainly the better team won there. Hopefully we will do better in the future, though judging from the past, that may not be the case. A little bit about myself. I am married with 2 kids. This is my wife and my 2 children. My oldest daughter is into gymnastics. My youngest daughter is into soccer, or as the rest of the world says, football. It's certainly something that I have really enjoyed getting to experience, and it's been a lot of fun. I continue to hopefully have a lot of fun watching these 2 sports. As far as my professional career, as already mentioned, I do a lot of turf pathology work. I do a lot of fungicide testing. I also do a lot of IPM. I do a lot of integrated pest management projects where we look at alternatives to chemistries to see if we can do things better. And we look to see how some of these cultural practices can impact the golf course. One of the things that I have worked on considerably is looking at the impact of turf fans on golf putting greens. I'm not sure how popular these are in Spain, but they have taken over in the United States, and let's see. They've taken over in the United States, especially in the southeastern U.S. and the transition zone, which is where we're located. One of the things we wanted to do is look and see how far the reach is for these turf fans. We're getting a lot of air movement close to the fans, but is that actually translating to an increase all the way across the putting surface? So one of the things that we did, as you can see in this image, we have a push cart that's got a sensor on it. This is measuring canopy reflectance. It's measuring the light that's bouncing back from the turf surface. We've got a GPS receiver, so we know exactly where every single measurement comes from. And from there, we were able to go through and map the overall quality of the putting green. As you might expect, a green and darker green is highest quality. Blues are average quality. Yellows, oranges, and red coloration is lower quality. So in this particular location, if you can see my mouse, we had a turf fan installed right along the edge, and we were able to use this reflectance mapping to show that we were getting the biggest benefit about 30 to 40 feet or so across the green. And then beyond that, we kind of lost efficacy. The fan was not providing that much benefit beyond, let's say, 40, 50 feet. What has come about from this is now some superintendents are able to look at a map like this and see that they have an area where the turf fan does not seem to be impacting. So if play allows, if it doesn't disrupt the flow of the golf course, in some cases they will add in a second fan just to make sure they get adequate coverage. This all started with me back in 2010 when I was putting out a standard fungicide trial with a lot of different products. And we went through and used reflectance mapping across an in-play golf course. And at the time we began the applications in early June, all of the plots looked the same. However, we did this reflectance mapping, and you can see a similar scenario where many of the areas were already under stress, already experiencing a decline in turf quality. And as the season played out and some of these areas began to break down, those were in fact the first places to show stress. So this really showed me the power that reflectance mapping can give you with kind of an early look at detecting stress. So that kind of gave me a jump start into doing this research. As far as some of the applications, for remote sensing, which I would consider this to be remote sensing, we also do a lot of hyperspectral radiometry. It's a unique way to measure reflectance from the canopy. It is very advanced. It is very innovative. However, it is incredibly expensive, and it is in no way practical at this point. So while we're still continuing to do this in hopes that 10, 15 years down the road, some of these things will be usable, we've tried to shift back to more of the things like I just talked about, where we're doing the reflectance mapping. This obviously also isn't practical when you're trying to map an entire golf course. So what we've done is we've taken the same sensor and we've mounted on the back of this fairway mower with the GPS and on the back of this greens walk mower, where we've got the sensor and GPS. And we're able to develop essentially the same type of map where we can look at stress in some cases before there's any visible signs. Somewhere along the way, I became known as the drone guy. I guess it's from where I was one of the first people to start using it and start talking about it in turf grass research. I now have a collection of 5 or 6 different types of drones. I'll kind of talk through those a little bit, and we're using them for different applications. Some of them are definitely not panning out. We're not having complete success, but we are having some successes, and I think we're doing things that will improve how we manage in the future. As far as what you can do with this, at least in the US, in the United States, people using drones on golf courses is becoming very common, and on athletic fields, on any kind of turf management. It gives you a unique perspective of what you're looking at, seeing it from essentially a bird's eye view. In this particular situation, we're working with one of our collaborators on a project where we went through and we flew actually a couple of drones over a lot of individual plots, and were able to assess the overall quality using that imagery. This is a picture over one of our research putting greens in Richmond, Virginia, which this is right in the transition zone where we really struggle to grow both ultra dwarf Bermuda grasses as well as bent grass or annual bluegrass effectively, just because it's such a difficult growing environment. This is an aerial image of the putting green taken earlier this spring as the Bermuda grass was attempting to come out of dormancy. The areas where you can see the dark green coloration is actually all that survived. Those are the areas that actually have living tissue where it's starting to grow early in the year. Everything else has been sprayed with a synthetic pigment, which is why you have a little bit of that greenish appearance, but for the most part, it is all dead. We were able to use this to zoom in and look at how some of the potential recovery options were working. In this case, we're looking at adding covers on in the springtime to see if we could promote some new growth. This is an image where we actually had we removed a black cover that would be absorbing more heat and transferring that to the turf grass. You can see it was somewhat successful. So we were able to use this aerial imagery to somewhat quantify how successful these treatments were. So what I would like to do is kind of talk about drones in general, because as I said, in the United States, it's becoming increasingly common for people to use this, both as a hobbyist, where you as a golf course superintendent may be out flying, or it may be a situation where you hire a private company, a private contractor to come in and do the flights for you. So we're going to talk about the three main portions of drones. We're going to talk about the platform, the drones themselves. We're going to talk about the payload, or the sensors that you're actually using to collect information. And we're going to talk about the data analysis. And I know the data analysis is incredibly boring. I get that, but that is really what drives a lot of these technologies. So in terms of the platforms, the different types of drones that are out there, we have, I don't want to say a saturated market. However, we do have a lot of options. You can buy things that are incredibly cheap, maybe 80 to 100 US dollars, to as much as 20,000 US dollars. So very, very expensive. In this image, you can see a little bit of everything. So this camera, or this drone that you see, the blue and black drone, is fairly inexpensive. It's about 150 US dollars. It works fine for what we need it to do. I see absolutely no problem with using something like this. This is a traditional quadcopter, so it's got four propellers that drives the flight. Just to the right, this is a Phantom that has also four propellers. It's much more robust. It's able to do a lot more things, able to capture high resolution video imaging, which certainly has its uses. Down in the bottom, we have, this is called a hexcopter because it's got 6 propellers. This is certainly more robust. This is actually one of mine that was built specifically for our program with mechanical engineers at Virginia Tech, to be able to carry the payload that we needed at the time. And I'll get into that in a minute. And then over on the far left, we have what's called a fixed wing. This is more like a traditional airplane, where you might actually physically launch this by throwing it into the air. You can collect a lot of information very quickly. It covers a lot of ground. So there's certainly pros to that. They're also very expensive. So typically for something like this, you probably want to have, you want to contract out to a service provider. There are definitely pros and cons to using drones, and the pros and cons go hand in hand. First of all, as I already mentioned, they can be very cheap, they can be very expensive. It really depends on what you're willing to spend, what makes the most sense in your situation. Second is the amount of information. You can get lots and lots of data. This can be a good thing and a bad thing. At some point, it becomes information overload. You have too much information to be able uh, to really comprehend what's happening. So again, that's a pro and a con. You get a lot of information, but then you have to do something with it. When you see things with a drone image, it is always just an estimation. It is something where you can say, all right, based on this image, we think such and such is happening, but you still have to physically get out there to validate what you're seeing. You have to go out and make sure that if you have a weed outbreak or an insect outbreak, you need to go out there and see for yourself that what you're seeing from the sky is in fact what is happening on the ground. This is non-destructive. You can get lots of information very, very quickly. You can figure out where your problem areas may be. However, that definitely requires some back-end data processing. Those are the things that are causing our bottleneck. That's what's causing us to slow down on the use of these technologies. And there's also just a ton of information. There's lots of data when you do this, when you collect aerial imagery. Okay, as far as the payload, the types of sensors are very important. You can get some very, very elaborate sensors. We have used multispectral, we have used hyperspectral, we have used thermal imagery. Those are all things that are, at this time, in my opinion, not cost effective. Really, at this stage, where we are now, some of the best information you can get is from a simple RGB camera. That's red, green, blue. That's your visible camera. Any kind of a digital camera that you use. I'm sure most people have a smartphone. The camera that you're using on there is strictly digital, and you can get a lot of information from each one of those pixels. Okay, as far as drone uses on golf courses, there's many, many uses, and then there's also, as I already mentioned, a lot of limitations. Right now, people are using this to really just get that quick and dirty view of what's happening across their property. By taking this higher in the sky, you're able to see larger areas at once. At this stage, in the U.S., we use the innovation adoption life cycle to talk about a lot of technologies. This is broken down into your innovators, those people who are trying new things. Many, many times they fail. That's kind of where I see a lot of these technologies right now. You've got your early adopters. I think as far as just basic drone use, we're to that point. We certainly have a lot of people who are using drones for unique applications. As we learn more, as we get to where we have more and more uses for drones and for some of these other technologies, you're going to get to where the majority of people are using that. And then there are some people who they're called the laggards. These are people who they don't like it. They don't like the change. They don't like the technology. They may never adopt something like this. And there's no problem with that. If it's worked well for you for decades, sometimes 30, 40 years, then why change a good thing? And that's completely understandable. I am a child of the late 1970s, early 1980s. One of the shows that was really popular when I was a kid was the Jetsons. This was this futuristic TV show that had all these robots, these flying machines, everything that was making day-to-day life, let's say, simpler. Not always the case, but essentially very, very futuristic. We're actually kind of getting to that point now. Here is LeBron James sitting in the back of a autonomous vehicle. This vehicle is driving around without an actual driver based on GPS coordinates. This is really taking off in many parts of the United States right now, and I believe it's taking off in Europe as well, and I think maybe London and Paris. On the golf world and on our side of things, you all may or may not have seen some of these technologies. This is a putting green robot that's going out and autonomously mowing the putting greens. Certainly, we've got a lot of people who are flying golf courses, flying their own personal drones, putting a lot of these aerial images on Twitter and other social media platforms. And then one of the other strategies, or one of the other new innovations, is the use of GPS guided sprayers, or global positioning system guided sprayers. This is similar to the push cart work that we did earlier. In fact, you can see this GPS receiver. This is a Phoenix Raven. That is the exact same model of receiver that I use for some of my work with the ground-based measurements. We're getting high resolution GPS coordinates from that. And the entire geometry of this sprayer is tied to this point. Is tied to exactly where the where on Earth the satellite coordinates are saying this is. Additionally, for this sprayer, we have individual nozzle control. So there's a solenoid for each one of these nozzles, so we can have that come on or off based on what the computer is telling it to do. Right now, I mentioned at the beginning that the golf industry wastes a lot. We do. I don't think it's by design. I don't think that we are trying to put out a lot of things unnecessarily. We just want to make sure we have the best surface possible. There is a true change in philosophy in the Golf Course Superintendents Association, in the research branch, which is the Environmental Institute for Golf. Excuse me. We are trying to shift gears to do more with less, trying to reduce our inputs and increase our efficiency. My home chapter, the Virginia Golf Course Superintendents Association, was one of the first chapters of GCSAA to post a best management practices publication. This is a guide that all golf course superintendents in Virginia are supposed to use to make sure they're doing things that are right for the environment, reducing inputs when possible. This is it's a little bit of a jumbled mess, but this is a graph that kind of we use to talk about a lot with turf grass. The y-axis, or the vertical portion, is turf quality. So the higher the turf quality, the higher it will be on this graph. Along the horizontal, or the x-axis, we look at inputs. You do nothing, you're probably going to have poor turf quality. As you start to put more and more inputs, whether it's pesticides, whether it is cultural practices like core aeration, vertical mowing, proper irrigation, whenever you put those inputs, you're going to have higher quality to a point. Once you get to a certain point, really the turf quality kind of plateaus, and it doesn't matter what you do beyond that, you're probably not going to have higher quality. Generally speaking, we, at least in the US, manage way out here where we're putting a lot of inputs into making sure that we have high turf quality. Why is that? We don't want to lose our jobs. Certainly in the U.S., there is a lot of stress on golf course superintendents. I assume it's the case for many of you, to where if you lose a lot of grass and there's things you could have done to prevent that, you very well could lose your job. So we do have this tendency to manage further out. We put more inputs in than we need. What I'm trying to do with my program is try to manage it more in this region, more in the area where you have less inputs. You're not sacrificing quality, but you're making precision guided applications so that you do not lose quality while still maintaining. Well, you reduce your inputs while still maintaining that high quality. This is something I see a lot. Javi and I talked a little bit earlier today about water usage and things along those lines. This is probably an extreme example, but certainly you have situations where people are turning on their heads, their irrigation heads all across the golf course, when really maybe 5 or 10% of the areas are what's starting to dry out. So how do we become more efficient and reduce our inputs as turf managers? So really the things that we can do as turfgrass professionals, first of all, we're working with biology. We're working with a living system, which is very complex. So as turf managers, we have to learn to work with this biological system. We manage people. That is very challenging. There are a lot of people, both who you may employ, or a lot of people who may be your clientele, who can sometimes be very difficult, to say the least. You have to manage those people. You have to manage budgets. I know that the conception or the perception around the world is that in the US we have unlimited resources in many cases, and whatever you need, you go out and you buy it and you use it. In reality, there is some truth to that, but we also on many golf courses are working within a tight budget to where we don't always have access to those resources. We certainly have to manage time as turf managers. That's always very difficult, making sure you get the right people at the right place. But then one of the other scenarios, we manage data. A lot of times when I talk to turf managers around the United States, when I say this, they're like, no, we really don't. And I say, yes, you really do. There's a lot of ways that we're already managing data. On most golf courses in the United States, people are now irrigating their putting greens based on localized conditions, where they're using a TDR soil moisture meter. That is probably the most common way that people monitor their soil moisture, so that they can go out and hand water only where needed. A lot of people are adopting in-ground sensors, where you bury sensors underneath the turf canopy. You can see that in this top image. We are also using, in some cases, equipment-mounted sensors to gather information, kind of like what I showed previously. We're using growing degree days, cooling degree days to determine when we make applications. We are now in the stage, in at least my region of the country, where we're keeping a close eye on soil temperatures so that we know when to make spring dead spot applications. There's also quite a few prediction models that are out there that many people are using for diseases such as dollar spot, insect problems such as annual bluegrass weevil, POA annua seedhead suppression. Okay, so this is one of the things I show to a lot of superintendents, and some people laugh at it. Some people shake their heads and say, okay, I can buy that. But whether we like it or not, we are moving into a situation where we're going from managing a little bit of data to managing a lot of data. We are getting to more of an automated system in the US across applications, whether it's industrial, agricultural, the turf industry, driving even, as I already mentioned. And where I see this in the turf world, again, it's using the drones to collect lots and lots of data, not just for the sake of collecting data, but this is more so that we can save time, we can save money, and ultimately save resources and send our resources where they truly need to be. This is just an aerial image we took when we flew a local golf course in Virginia, where I'm located. This is a composite image of roughly probably 200 to 300 single still shot images. This is probably somewhere in the neighborhood of 250, 300 million data points. And it's an extreme amount of information. Everything about it is an estimation based on kind of what we perceive those digital values to be, which I'll get into in a little while. Like I already said, in order to make any of this be useful, in order for the turf manager to gain an advantage by doing this, you've still got to get out there. You've got to look and see what this imagery is telling you. The technologies are improving, the costs are coming down considerably. So as we keep learning more and more, I think this will become more practical. One thing that is important to note, it is the last bullet point here. This is a snapshot in time. This is what your golf course looks like at the time of this particular flight. Things change. You know they change based on what you're doing every day when you're out across your golf course all day, every day. So you can't fly one time and assume that you're going to know where your dry spots are, where your disease outbreaks are. This is something you have to do more routinely. I mentioned before, it's a lot of data. There's so much information, and this is the boring part of it, but this, in my world as a researcher, this is where we really try to utilize computer automation. We try to go in and find that needle in the haystack, find that one bit of information that can help us determine whether or not you have a disease, whether or not you have an area that's beginning to dry down before you can see it. Okay, how are we using some of this imagery to make better decisions? I'm going to go through some of those specifics. If you look at this image, you see that you've got ducks. How do we know that's ducks? Because we've seen ducks thousands of times, and we know that's a duck. Basically, we manage turf grass based on what we see, and that visible information is kind of what drives our decisions. We learn these things from repeated visual learning. This is based on spectral properties, that light that's actually bouncing back from the surface. When we're looking at the grass, we're actually looking at the light that's being reflected from the canopy. As I already mentioned, any digital camera, any smartphone, a camera on a drone, that has specific digital properties. We can use those to our advantage. And then if we do things properly, we can use computer automation, computer learning to be able to glean information, to interpret what we're seeing from that map. Here's just a few of the problems we see as golf course superintendents. We can see crabgrass germinating. We can see various POA, Annua trivialis, Kentucky bluegrass, agrostis, creeping bentgrass. We can see when we have contaminations in across our golf courses. We can even use Google Maps. This is certainly something I spend a lot of time on just because I'm fascinated to see what you can see from the sky from a plane that flew by 2 years ago. I would imagine many of you have probably used Google Maps across your golf course, and you may have kind of stumbled across something where you said, hey, I didn't realize, there's this feature, whether it's maybe an area that's drying out and you find out you've got some rocks embedded right beneath the surface, or in this case, you can see a lot of creeping bentgrass contamination in a Kentucky bluegrass rough situation. And again, this is strictly from Google Maps or Google Earth. Free information. As I mentioned before, each of these pixels, you've got thousands of pixels on this one particular screen. If you use a certain type or a certain type of software, you can go through, you can click on a pixel, whatever that may be, and you're going to get 3 numbers, actually 4 numbers. Your band 1, 2, and 3, that's going to be your red, green, and blue saturations, and that band 4, that 255 that you see, that is kind of your maximum exposure. So really, the combination of that red, green, and blue, that's in this case a 117, 123, and 54, that is going to tell you something about how green or blue or yellow or whatever that particular image may be. Okay, digital image analysis is something that we've been doing in turfgrass research for quite some time. In most cases, it's light box. It's a controlled environment where we can get some useful information. However, we can only get a small snapshot. I have really began doing a lot of aerial imagery, as I've already mentioned several times, to see what we can actually do from the sky, from, in many cases, 50 meters, 80 meters away from the surface. There we go. So this is one situation where we have used digital image analysis to detect a disease. This particular disease is spring dead spot. I wish for this particular image I would have put a side by side so that you could actually see the spring dead spot behind, but I do not have that right here. But this was all computer generated. We had a couple of different models that we used to where we could be very conservative and say, we think it may possibly be spring dead spot, therefore we want to get the coordinates. And we've also been very aggressive with it, which is more of like the yellow that you see, where we say, all right, we know this is spring dead spot. We want to try to eliminate everything else. We've kind of found a sweet spot with what we've done, and we've developed a particular algorithm that we can use. These are some pictures that we've taken from aerial images on the top. This is from one year to the next where we had some fungicide applications. This 1624 that you see in your top left was from 2016. You can see 1, 2, 3, 4, 5, 6, 7, 8 patches, it looks like. We sprayed that with what I would consider to be a very effective fungicide, went to that exact same spot, and we had a clean plot the next year. In this next plot, the 1628, you can see a couple of patches in 2016 where whatever we applied was not effective, or maybe we didn't spray anything. You come to the right side, that's the exact same plot 1 year later. Those same spots are there, and not only are they there, but you can see where they've actually expanded. Now, when we digitize this, down on the bottom, you're going to see the same features. You see from the left side, the 1629, I think I said 8 spots. We've got the 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the same detection. Over here, it looks like we may have missed some of it, some of the spring dead spots, but we picked up part of it, and then we picked up another small patch in the lower corner. And then the same situation for 2017. What we've also been able to do is we've been able to assign a % disease for each one of these plots. So a lot of times people will say, you know, I've got a disease, I've got snow mold, or I've got dollar spot that is everywhere. We can use this imagery, and I'd say, okay, you've got a situation where you think you've got a lot. That is actually 1.5% of the area that's affected. It may be a lot still, but it's not really nearly as much as what you think, if you can find a way to get down to treat those things locally. Okay, so some of the reasons for developing this, and I've already kind of gone through this earlier. The objective quantification of field studies, it's rapid, it's quick. That's what I was just showing right here. We're able to use the digital image analysis to track how well our fungicides that we apply are actually working from one year to the next or over the course of a season. As a plant pathologist, I am certainly interested in the epidemiology or the spread of the disease over both time and space. How is it moving across the golf course, and how is that moving, how is that spreading over the course of a season or from one year to the next? We can use these maps to be able to do that. And then the last, the final thing, and this is really where I think we are as an industry, it's actually using this as a platform for site-specific management, where we can make targeted pesticide applications and reduce the overall inputs and keep some money in our pockets. So the overall gist of site-specific management is fairly simple. It's using the right practice at the right place at the right time. That's something that you've probably been doing for years. Some of you may know you're doing it. Some people may just do it just without even giving it much thought. Part of what we're doing is trying to see how we can make drones, site-specific management, and precision turf management all fit together. We can do that with both, well, with a lot of situations, everything from irrigation, fertility, cultivation practices, use of wetting agents, and certainly pesticides. Pesticide is the primary situation or primary input that I'm looking at. And the basic premise of precision turf management is it's site-specific management. I'll have this slide up here if you want to go back and look through this information at a later time. But again, it's what I said before. It's putting the right product at the right place at the right time. This is something that I do teach a class with Dr. Gerald Henry from the University of Georgia at the Golf Course Superintendents Association of America annual meeting. If any of you are coming to the golf industry show, certainly that's something that you can look into if this is something that interests you. And of course, my computer seems to have locked up. All right, there we go. This is just a snapshot of one of the projects that Dr. Henry and one of his grad students did, where he was looking at a soccer field, or actually a football, American football field in this particular case, where they can track where the compacted areas are across the field. You would as you would imagine, the areas that receive the most traffic in American football terminology, that's inside the hashes, where most of the action occurs, is where you see the most compaction. You can use a map such as this to go in and only aerify, only reduce compaction in just those areas, as opposed to having to do it across larger surfaces. This is some more of his work. I wanted to include this as well, where he was able to tie in a paspalum outbreak with some of the underlying soil variables, and they're able to say that, show that soil does impact what type of or where you're going to see your pest outbreaks. Here's a spring dead spot. This is the disease that I have focused a lot of my efforts on over the last few years. As you can see, it's a very severe disease. In a situation like this, if you don't want this to happen again, you're going to have to treat that entire area. If you have historical maps, you'll know where you can go back to. This is like a worst case scenario of what we would expect to see, at least in our region. However, if you kind of step back, use drone imagery, you might see that not all of the areas are like that. You may have isolated areas. This is a drone image that we took several years ago where we were looking at spring dead spots, and you can see areas right along the fairway line, areas that were probably compacted, and then this area off into the fairway. Of course, you've got your golf cart traffic. You can see the wear. That area is probably compacted because of golf cart traffic. So in reality, rather than spraying this entire fairway, you may be able to pick out the areas where the disease is and only go and treat those spaces. This is just an image. We had a group of visiting turf managers from Argentina. We were out looking at a golf course in Virginia, and we had this one area where there was a lot of spring dead spot and everything else was clean. Here it was pretty obvious. They accidentally either turned off the sprayer or ran out of product, and they had a missed application. But this is a situation where you can clearly see that those areas had much more disease than anything else. So one of the things that I will focus on for the last few minutes here is a project that we have done with the Environmental Institute for Golf in partnership with the Virginia Golf Course Superintendents Association, as well as Toro, Turf Scout, and the Unmanned Systems Lab at Virginia Tech, where we are trying to make precision guided applications. This is using both the sprayer that I already talked to you about and drones. Essentially, what we want to do with this study is we want to put all the puzzle pieces together. We're starting off, we're going and using the drone to fly the golf course to collect these hundreds of images. And then we do post-processing to put all these images into one cohesive map to make a stitched image is what we refer to this as. Then we went through and we wrote algorithms that we would plug into this post-processing software to be able to detect the areas of interest. In our case, it was the spring dead spots. Then we had to take the GPS coordinates of where those maps said we had spring dead spots and bring it over to the sprayer so that the sprayer knew where exactly on Earth, where in space those particular spring dead spot locations were. Each one of the spring dead spots had a precise GPS coordinate associated with it. Then we went out and made the precision guided applications. Then after that, we waited. When the time was right, the following spring, we came back and we flew the golf course again to assess how successful we were. And our ultimate goal here again is to reduce the total acreage needed to treat this particular disease. And we seem to be stuck again. I don't think the computer likes when I have a lot of words on a slide either. There we go. All right, so basically the quick and dirty, or the quickly, we were looking at green versus brown. This was a perfect test disease because it's very cut and dry. It's either a green Bermuda grass fairway or it is a brown dead spot. We know that spring dead spot comes back in the same place each year for several years, so we thought this would be a great opportunity. I've already kind of gone, well, we're stuck again. I've already gone through and kind of explained our methodology. We went through, we flew the property. This is going back to 2016, I'm sorry. Built our maps, had individual plots that showed where our disease was, and then we went through and we sprayed only where needed. Basically, when we looked at the diseased area, we have for each of these, our light green is untreated, our darker green is tebuconazole, which is it's a relatively inexpensive fungicide in the U.S. However, it's not that great at reducing spring dead spot. As you can see, we have a broadcast blanket application of penthiopyrad. That is Valista in the U.S., which is one of our most effective spring dead spot fungicides. And then we also have our site-specific management, where we only treated those areas that we needed. Statistically, when you look at this, we actually had equivalent control with both our site-specific and our blanket applications. There's a little bit of increase that you can see for some of these. That is because we are not hitting, we're not affecting the new patches that may begin to develop. Those are typically going to be very small and you can grow out of that very easily. We went through, we mapped where the locations were, and then we used the sprayer. This is kind of a map showing how we treated. The red areas are plots where we had the site-specific management, and you can see, let's say for this particular plot, 1570, we only had one area where we actually had to spray. Some of these plots may have also been site-specific and there was no disease, therefore we didn't have to spray the plots. This is just kind of a close-up showing what it looked like. For each one of those GPS points, we created a larger buffer because we wanted to be more aggressive. We wanted to make sure that if we weren't positive how close our GPS was, so we wanted to make sure we started and stopped before that actual patch to make sure that we didn't miss the area. We did have the individual nozzle control. I already talked about that using the Toro GeoLink RTK. That is very precise. For us, we were able to get within about a quarter of an inch or about 1 centimeter of accuracy, which was very impressive. We built the maps. Like I said before, we plugged it into the sprayer. And then here's what some of the maps look like. You can see these green areas, those are our squares. Those are our blanket application where we just drove across like you would with any sprayer. And this was telling us where we actually needed to go and spray. On the right side, you have these smaller dots. This is basically where we went through and treated the spring dead spot. You can see the green areas, that's where we've already sprayed. I can drive around that all day long, and I'm not going to spray it again based on the way I've got it set up. Now I'll compact the soil and have more spring dead spot later, but it's only going to spray at one time. So the results of this is kind of the most important part. We were able to reduce our fungicide inputs by 65%. I'm very proud of that using the site-specific management. And I'm also, again, happy to say that we were able to do this without sacrificing control. We were just as effective. We did have those new infections, but as we continue to go and do this over the course of several seasons, we will be able to pick up those new spots, and each time we'll get hopefully from 65% to 75% to where in time we'll be able to get maybe 90% or more reduction. And just to wrap things up, because I'm now officially at 6 p.m. your time. Again, this is the innovation adoption life cycle. We are still in the infancy. We're still in this innovator stage. We are trying to move the technology along so that we can spread this to the vast majority of superintendents. Hopefully within the next 2 to 3 years, we'll have more of these early adopters. And within the next 5 to 10 years, we'll start to see the majority of people utilizing these. And at this point, that's all I have. I am now 1 minute over my time, so I'm happy to answer any questions that you may have. I'll close this off And let's see. So I've got the chat. I'm happy to answer any questions. Javi, I guess if you can chime in. I'm not sure if.
Yeah. Hello, David. Thanks.
Yes.
First of all, thank you very much for your presentation. It was really interesting. So
I'm happy to do it.
thank
Thank
you,
you.
thank you for your work, and I think it's a very interesting topic to work on.
Yeah. Well, thank you.
Thank you. So right now there is no questions, but let's give to the attendees some time in order they can write it down in the question
Okay.
in the question box.
That's fine. Well, while we
Okay.
are waiting for people, if anybody does have any questions, one thing I forgot to do, I guess you couldn't see me anyway before. I do have a couple of my drones here in the
Yes.
room. So this one right here is the large hex copter that we had built. We really, honestly, we don't use that much anymore. It's nice, it's fancy, I can show people, but it is not as useful right here. I can't pick it up because it's about 5 or maybe a meter away. But this one is very small. It's something that's useful. This is probably one of those starter drones that if a superintendent is interested in just exploring, seeing if it's something they want, it's not that expensive. It's probably a good place to start. But this is my baby. This is the one that we use the most often. Still not too expensive. It's a Phantom Phantom 4 from DJI. This is the camera with 20 megapixel resolution. We use this small drone to build our spring dead spot maps. So um, it's simple, it's easy to use, it's dummy proof, so somebody like me can use it without wrecking it too often.
Okay. So from a golf course superintendent's point of view, are we gonna lose our job? Are we gonna lose our job?
No, no, you absolutely will
Just
not lose your job. No,
no.
people joked about that when I've talked with a lot of superintendents around the country. When I talk about these, no, no, honestly, your job is going to be that much more important because you've got to be that voice of reason, that agronomist that knows what the maps mean. Um, you've got to be the one that goes out there and makes sense of the maps, and your job, I think, will be just as important, if not more important, moving forward.
Okay. Now seriously, under your under your point of view, which will be the next step on using
Um,
technology applied to turf management?
the next step, I think what I was showing there towards the end with these GPS guided sprayers, we already have a lot of those early adopters in the US who are using that when they build basically they'll go through and make an outline of their fairways, their tee complexes, their putting greens, to where only those areas are being treated. And the simple savings in just doing that, depending on who you talk to, is going to be somewhere between 12 to 20% reduction in total total pesticide use, just from making sure the boom turns off where it's supposed to.
Okay. Okay. There are several questions, so if you want, you can see them. So I'm going to read for you.
Okay.
Let me see. Let me check it. Yes, the first one, Francisco Blázquez, is so he looks very interested, and he's asking where he can get more education in this topic.
Come on to America. Certainly at the golf industry show, we have the The session that I talked about, it's a 4-hour session. They asked us if we wanted to do an 8-hour session. We're going to wait for probably one more year before we make it a full day where we do this training. I know there are other researchers around the country who are doing similar things. So I think that there are definitely opportunities for more webinars, for more training. Javi, do many of the superintendents travel to the European Turf Society meetings, or is that mostly for the researchers?
Great. And another question from Nicolas Marin. He's asking about the program and how is working the program to analyze the digital images.
So how are we working through the problems with analyzing? We've got people smarter than me. It's got to be people smarter than me. We're working with computer engineers, computer scientists, mechanical engineers. We can go through and we can tell them what we're interested in. We go out for the ground validation and we get our GPS coordinates, and then we look for those spectral properties that fit what we're interested in. Let's just say common Bermuda grass will have a different overall digital color than some of these improved varieties. I don't know how many improved varieties you're working with, but we have 15 or 20 fairly common Bermuda grasses here, and you can just compare the digital contrast. It's something it's difficult up front, but once we get more involved, it becomes easier and easier.
Perfect. Another question from Bernardo Almeida says, hello, do you get information from drone as to hydric stress and nutrients? How many minimum flights per year should be done?
Okay, so the question is, how many flights do we need in order to truly be able to understand the drought stress and nutrient stress? Yep. It really depends on the situation, and I hate to say that because I know people want a specific number. Yeah. What I would say is initially across your golf course, try to fly somewhat routinely during drought conditions or early stages of drought. Say you go 4 or 5 days without any rainfall, and if you do not turn on irrigation, you'll start to be able to see some areas starting to dry down. I would say those first days you start to see anything dry, if it were me, I would go out, fly the property at that point, and then maybe the next day and the next day and the next day. So maybe 3 or 4 times clustered together, and you're going to see those areas that begin to dry out. You're going to know which areas on your golf course you need to really pay attention to.
Okay, another question. Lorena Parra, she's asking if would you recommend to use only the RGB cameras to get information?
We've done a lot.
Your research?
Yeah, so with my research, we've done a lot with the multispectral. There's definitely places where those come in handy. For something as simple as, is it green or is it brown? That really, you don't need to go to spend the extra thousands of dollars for something like that. Now, for the early detection, certainly we have seen a lot more utility when you get to these very expensive cameras. There's one hyperspectral camera that costs about $100,000 US. I don't have it because I can't afford it, but if you had something like that, I think you could really use a lot. You could really tell a lot well in advance of any symptoms beginning to develop.
Okay, another question, Antonio Pedro from Portugal. He says, in our golf course, we already had some presentation with drone images, but nothing very specific regarding golf courses issues, like certain diseases or weed infestation like paspalum. Will we have such a service? Will we have such? So sorry, I don't understand the question, Pedro. If you can,
I
okay.
think I understand what
Yes.
you're saying, and basically it sounds like he's had the same service that a lot of people in the U.S. have had. Somebody came out, they flew the golf course, they got these beautiful images of their golf course, and now what? You're left with a bunch of nice pictures. What are you going to do with that? The
No,
way I,
sorry. I understand. He's asking if he can get this specific service in Europe. So if I understand that he's asking about where in Europe he can get this specific service on golf courses.
I really don't know the answer. I'm not
Okay.
sure what private service companies are out there. Um, so I don't know.
Okay. Another question, Kerem Mesa. He congrats you. Good presentation. He says, what type of camera do you recommend to measure turfgrass and the VI by drone?
So NDVI, I did not really get into NDVI at all today. That is by far the most common index that is out there. That's the normalized difference vegetation index. Basically, you're looking at red light to near infrared light, and you're looking at a ratio there. We have looked at this a lot, and it can give you a little bit of advanced detection, but really, I probably have gotten myself into trouble in the U.S. several times in saying that it's kind of an old, dumb index, and it's going to tell you there's something happening. You just don't know what. It will lead you in the right direction. As far as a specific camera, the one that we use that we've been the most pleased with, there's one called the Mica Sense Red Edge. Um, it's and actually I guess I had pictures of it somewhere in my presentation. But it's something that has visible light, near infrared light, and it also has that red edge region between what you can and cannot see. And I think that particular region can be very useful. I think that's going to greatly enhance um, your imagery more so than just a straight NDVI.
Okay, Francisco Blázquez. He says he's living in the Middle East, and he was asking you before about where or which is the best university or any other educational center where he can learn more about this technology. And he says he's willing to move to states. So if not, you can give your contact details, your email, and if you want, you can Francisco.
So
You can contact with him and give him the information about it.
okay, now
And
you want to know about the universities in the Middle
yeah,
East
no,
or
in states.
Oh, okay.
In the states.
There's quite a few that are doing these types of things. I will say that Virginia Tech as a whole, um, we are one of those universities that's really committed to automated technologies. I am a small fish in this massive pond here at Virginia Tech, where we've got a lot of researchers, but there's absolutely other great universities, and I will I'll have my email. I'll try to show that again, and certainly he can email me and we can discuss in more detail.
Okay, great. I think that will be the best for
Yep.
him as well. Okay, so David, there are no more questions. Thank you very much again. I think that there is I just realized that there is a lot of interest about this topic. So if you think that we can schedule another webinar to give another presentation about this topic, feel free to tell it to me, and we
Okay.
can do it. So I think it's interesting to keep updated on this topic.
Certainly, I'm glad to help anytime, and I'm glad to give you some names of some other people if you want a different perspective. Real quick, if you can you still see my screen?
Yes.
Okay, so here is my email address. I'll do this so in case anybody wants to email me with more questions, it's ds and my last name MCCALL at vt.edu, and I'll certainly be happy to answer any questions.
Okay, thank you. Perfect. So, okay, thank you again for your time because it's 6:17. So thank you again.
All right. Well, thanks for having me.
And again, feel free to keep to let's keep the contact. Let's keep in touch. And seriously, we can schedule another webinar about this topic. I think it's interesting. It's very interesting.
Okay. Yeah, happy to anytime.
Okay.
All right,
So
great. Thank you.
let me say bye bye in Spanish to people. Bueno, pues bueno, pues nada. Creo, como le decía ahora a David McCall, pienso que es un tema interesante. O sea, si estáis interesados en que profundicemos un poquito más en este tema, pues escribís a mi correo a info@campusdecésped.com y bueno, en función de la demanda organizamos otra charla al respecto. Como bueno, el próximo webinar será el 29 de octubre, que lo haremos con el profesor Clint Waltz de la Universidad de Georgia. Nos hablará de la resiembra otoñal en campos básicamente de Bermuda. O sea que a lo mejor iremos un poco tarde, pero bueno, será interesante también ver el tema de las resiembras, que va ligado con el de los pigmentos, que todavía lo estoy intentando organizar, pero estas fechas son complicadas para los profesores. Veremos a ver si tenemos éxito. Muchas gracias, como siempre, a todos nuestros partners. Ya sabéis que es gracias a ellos que vamos funcionando. O sea que, bueno, pues nada. David, thank you very
Yes.
much, and I hope to see you soon.
All right. Thank you. All right.
Bye
Bye.
bye. Bueno, pues muchas gracias a todos y hasta la próxima. Adiós.